Okay. Now over here in number 13, we're trying to solve this quadratic. Not many of you somehow had questions about this one. I guess you had gotten really good at doing your factoring work. This one is fairly easy to solve by factoring. Remember, with factoring, we're looking for two numbers that multiply to c, which in this case is 45, and add to negative 14. So in this case, that's going to be 5 and 9, but we need to make them both negative so that it adds to be negative 14. So that's going to yield 0 equals x minus 5 and x minus 9. That is the factored expression of this. They're exactly equivalent. And then we split each individual factor and set each individual factor equal to 0. So x minus 5 equals 0, x equals 5, or x minus 9 equals 0. Adding 9 on both sides gives us x equals 9. That's all that we had to do for number 13. That's probably why not many of you had questions. Oh, that's my watch. Okay, number 14. The easiest thing to do is to recognize, since there's only one x, to solve this in reverse order of operations. All right, so I'm going to list out, normally I just think through my order of operations, but here I'm going to literally write them out. The very first thing that I would need to do is parentheses. So in normal order of operations, we're going to do minus 4 first. Then after parentheses comes exponents. So we're going to square. Now we do multiplication or division, in this case times 2. And then there's no more operations to do. So now when we solve it, we want to work backwards. So from the bottom to the top. So step 1, we have to undo times 2. How do I undo times 2? Divide by 2. We have to undo squaring. You undo squaring by taking technically positive or negative square roots. And then how do we undo minus 4? With plus 4. Okay, so 2x minus 4 squared equals 98. First thing we're going to do, we're going to divide both sides by 2. That's what I wrote down over here. We're going to divide both sides by 2. X minus 4 squared equals 98 divided by 2 is 49. Step 2, we're going to take plus or minus the square root of that. So x minus 4, when I take the square root of this side, x minus 4, because square roots cancel out squares, and that's plus or minus, equals either positive or negative 7. And then finally, we're going to add 4. So x equals 4 plus or minus 7. Well, 4 plus 7 is 11, or negative 3. Because 4 minus 7 is negative 3. Okay, and now in number 15, we're back to solving a system. If you had tried doing elimination, if you had tried doing anything besides substitution, this is going to be a little bit slower. But you should have recognized that this equation is basically solved for. If 2z equals 8, then z equals 4. And now if z equals 4, would you look at that? This one becomes very easy to solve. 4x minus 4 equals negative 8. Add 4 to both sides. Gives us 4x equals negative 4. X equals negative 1 when we divide both sides by 4. And now we can plug both of those in to our original number 1. I'm just going to rewrite the exact problem as it was. 2x minus 3y plus z equals 7. And now I'm just going to substitute. 2 times negative 1 because that's what x was, minus 3y plus z was 4 equals 7. So that gives us negative 2 minus 3y plus 4 equals 7. Negative 2 plus 4 is going to give us negative 3y plus 2 equals 7. Subtract 2 from both sides. Negative 3y equals 5. So y equals 5 divided by negative 3. Okay, and then number 16. Maximum height. In order to find a maximum, we're really looking for the vertex. The vertex is given, the x of the vertex is given by negative b over 2a, and the y of the vertex, you find it by plugging it in. So this is b, this is a. The vertex is going to occur when x is whatever negative b over 2a gives us. So negative 224 over negative 16. Again, this is your x. And 224 divided by negative 16 is going to be 8. 8? No, not 8. 14. Oops. Messed up a few times. So I did negative b over a, but it's negative b over 2a. Okay. And that is going to give us an x of 7. I hope. Yes, 7. And now that only gave us our x. We still have to find our y. We find our y by plugging that in. Y equals negative 16 times 7 squared plus 224 times 7 plus 36. 7 squared is 49. So negative 16 times 49 is going to give us, I wish I had a calculator handy, 784, negative 784. And then this is going to give us plus 15, 68 plus 36, and then adding all of those together will give us 820. All right, so that is the maximum height of the rocket, 820 feet. All right, the value of the y-intercept, well, the y-intercept is just found when x equals 0. So plugging in 0 just leaves us with 0 equals 36. Sorry, y equals 36. Because this becomes 0, this becomes 0, and so we just have plus 36. And in real life, that is the height initially when t equals 0, or when x equals 0, when the time is 0. All right, so it turns out, in fact, that would be the height of the tower. Okay, and the x-intercepts, this one was a little bit harder to do mathematically, but the x-intercepts, in real life, we can answer that part first. X-intercepts in real life are going to be when the height is 0. Or when it lands. All right, and so that's when your height is 0 or when your y is 0. So we're going to have 0 equals negative 16 x squared plus 224 plus, x, plus 36. And now I would recommend solving this using the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now plugging in our particular values here, x equals negative 224 plus or minus the square root of 224 squared minus 4 times negative 16 times 36, squeeze that in, all over 2 times negative 16. And then since I don't have a calculator handy, I'm not going to try doing that in my head. But, oops, and you guys can't see all of that. But you would solve that by just plugging that into your calculator. Make sure that that matches exactly the way that it appears in your calculator. Okay. But I can tell you it'll be a little bit less than 14 seconds. I remember that from the test itself.